Okay, let's see if the inverse square law actually works. To test it, we need a number of lights, all of which are actually the same, but a range of distances. Luckily, we have this avenue here in Canberra, Anzac Parade, which has just such a set of streetlights at a range of distances, but all really the same. Notice the kangaroo over here watching the scene. So what I'm going to do is take a bunch of lights, actually on this side. I'll take the front light of each of these pairs and measure how bright they appear to be, as taken by my camera, and compare it to the distance. Now I can't use this image because, as you can see, the lights are just too bright. They've saturated the detector. So what I need to do is take another image with a shorter exposure time, which you can see here. So now all you can see is the lights we're going to use. We're going to use these ones, the front one of each of those pairs, and we're going to measure how much light we're getting from them as taken by my camera and compare that with the distance. Now, one complication is that the camera takes color pictures. What I've done here is split the color picture into 3 different bands, a blue, green and red one, and this image here is just the green light. So you get similar answers if you use the red or the blue bands. Inverse square law works at any wavelength. Here is the image of the nearest of the lights. You can see high intensity in the middle, low intensity over here. These are the pixels, and you see these pixels collected lots of light, and these pixels didn't collect very much. We can visualize this as 3D, as a sort of histogram, where you see all the different pixels, and the height here tells you how much light was detected in that particular pixel by my camera. And to work out the total intensity of all the light received from this light, you just have to add up the values in all these different bins, which I did using a small Python computer program. And here is the same sort of diagram for the furthest light. If you look at it as an image, you can see it covers fewer pixels because it's further away, but looks kind of similar. And once again, you've got more light detected in the middle and less down around the outsides. And once again, you add up the heights of all these pixels, intensities, to work out the total brightness. And we can now plot the intensity of all these lights. Here the nearest one, the further ones, these are the green circles, against the distance to them as measured off a map. And this is the total flux measured, the total sum of the intensity in all those pixels. And the red line is an inverse square law, and you can see it's a pretty good fit to the data. Not quite perfect, the lights are not totally uniform, in particular some of them are tilted towards or away from us a little bit, but actually pretty good. It seems that the inverse square law really does work on Earth as well as in space.